So children, before we start with the class, let us see the pledge. Place your right hand on your heart and please repeat, I, Shruti Narayan, commit to be vigilant and bear in mind at all times the risk to myself and my colleagues from COVID-19. I promise to take all necessary precautions that prevent the spread of this deadly virus. I promise to follow and encourage others to follow the key COVID appropriate behaviors. To always wear a mask, face cover, especially when in public places, to maintain a minimum distance of 6 feet from others, to wash my hands frequently and thoroughly with soap and water. Together, we will win this fight against COVID-19. So children, in the previous class, we had studied about the major pressure belts of the earth, which are the equatorial low pressure belt, the subtropical high pressure belt, the subpolar low pressure belt, and the polar high pressure belt. We had studied about their latitudinal locations, and in today's class, we will be studying about the shifting of the world pressure belts. Since pressure belts on Earth are caused mainly due to differences in temperature on the surface of the Earth, the pressure belts move in response to the apparent migration of the Sun. The Earth revolves on its orbit around the Sun in 365 and 1/4 days. The Earth is inclined on its axis at an angle of 23.5 degrees. Because of the revolution of the Earth and also because of the inclined axis, the relative position of the Earth with respect to the Sun changes. Between December and June, the Sun moves northwards, and between June and December, the Sun moves southwards. Therefore, the pressure belts follow the annual migration of the Sun towards the north between December and June, and to the south between June and December. As you can see in this diagram, the Sun shines vertically over the Tropic of Cancer on June 21st. If you remember, we had studied, which is called the summer solstice. Then the Sun appears to move southwards until it shines vertically over the Tropic of Capricorn on December 22nd. After December 22nd, the Sun seems to move northwards until it shines over the Tropic of Cancer on June 21st. Now in this diagram you can see that on March 21st and September 23rd, the Sun is overhead at the equator. So on March 21st, the Sun is overhead at the equator as the Earth continues to revolve around the Sun in its inclined axis. The northern hemisphere gets tilted towards the Sun. Therefore, on June 21st, the rays of the Sun fall vertically at the Tropic of Cancer. Further, as the Earth continues to revolve, when the Earth reaches September 23rd position, the rays of the Sun fall vertically at the equator once again. So March 21st and September 23rd are the equinoxes. As it continues revolving, on December 22nd, the rays of the Sun fall vertically at the Tropic of Capricorn, which is called the winter solstice. Now let me explain this diagram. On March 21st and September 23rd, the Sun shines vertically over the equator. So, all the pressure belts are in their original positions. As you can see in the diagram, the equatorial low pressure belt lies between 0 to 5 degree north and south of the equator. Then, the subtropical high pressure belt lies between 30 to 35 degree north and 30 to 35 degrees south. Now, as the Earth continues to revolve around the Sun, on June 21st, if you see in this diagram, what happens is the Sun is overhead at the Tropic of Cancer and all the pressure belts move about 5 degrees towards the north. In the above diagram, you can see that the equatorial low pressure belt is shown more towards the north of the equator. Now, the equatorial low pressure belt lies between 0 to 10 degree north, as you can see in this diagram. Further, the subtropical high pressure belt in the northern hemisphere, it has shifted to 35 to 40 degree north. And in the southern hemisphere, the subtropical high pressure belt has shifted northwards towards 25 to 30 degree south. So, in this diagram, you can see that on June 21st, when the northern hemisphere is tilted towards the sun, all the pressure belts shift by 5 degree towards the north. Now, again, when the earth continues to revolve, when the earth comes to September 23rd position, all the pressure belts come back to their normal positions. Now in December, on December 22nd, the sun is overhead at the Tropic of Capricorn. All the pressure belts move about 5 degree towards the south. Now here you can see, if you make a comparison between the diagram of 21st March and 22nd December, you will see that on 21st March and 23rd September, the equatorial low pressure belt lies between 0 to 5 degree north and south. While in December 22nd, the pressure belts have shifted southwards, so now the equatorial low pressure belt is between 0 to 10 degrees south, and the subtropical high pressure belt in the northern hemisphere has also shifted southwards. It's between 25 to 30 degree north. Similarly, in the southern hemisphere, you can see the original position of the subtropical high pressure belt in March is between 30 to 35 degrees south. But on December 22nd, you can see that the pressure belt has shifted southwards by 5 degrees. So now it lies between 35 degree to 40 degrees south. So the effect of the shifting of the world pressure belts. The pressure belts greatly affect the direction in which the winds blow. Hence, the shifting of pressure belts causes some places to be in different wind belts during the year. As the wind belts shift with the season, the belts of precipitation related to the wind belt also changes. And a very good example of this is the Mediterranean region that lies between 30 to 45 degree north and south. It comes under the influence of the trade winds during the summers, and during the winters, it comes under the influence of the westerlies. Now, if you see in this diagram, in the northern hemisphere, the Mediterranean region that lies between 30 to 45 degree north, it comes under the influence of trade winds, which do not cause any rainfall. Whereas in the southern hemisphere, the Mediterranean region comes under the influence of westerlies, which gives rainfall to these regions. Now in December, what happens is, if you see in the northern hemisphere, the region between 30 degree to 45 degree north comes under the influence of westerlies, which give rainfall. Whereas in the southern hemisphere, the region that lies between the region that lies in the Mediterranean belt, that comes under the influence of the trade winds. So these trade winds are offshore and they do not cause any rainfall. So this shifting of world pressure belts has a great impact on the regions which experience Mediterranean type of climate. A chief characteristic of Mediterranean type of climate is that they get rainfall during the winters from the westerlies. The westerlies, if you remember, they give rainfall along the western margins, and during the summers they come under the influence of the trade winds, which are offshore on the western margins, and they do not cause any rainfall.